Hi everyone, a very pleasant good morning to everyone and welcome all to the Digital Transformation Program from tsat. So it's been a pleasure being part of this program and tremendously it's a good program to be and part of good initiative also. So it would actually be a plus added advantage to all of the career growing students and put their careers on all the part and to grow in their aspects of life. It's actually an appreciable initiation. So I'm glad to be part of this program. So before going to actually the content of the program, so today I'm here to talk and discuss on a very interesting topic, that is IoT and cloud computing. So before going to the topic, let me introduce myself. This is Asha Swarupa, working an associate staff engineer in Silicon Labs India Private Limited. So before actually I move into the session, let me make you understand what exactly Silicon Labs is for and what my company do in the aspect of market. So this is where I can show you where we are in the modern Silicon Labs, the leader of IoT wireless. So we are the masters and the leaders of IoT wireless in the market domain. So we give a chipset domains to the market with a very small chipset and with all the Wi-Fi and Bluetooth and Thread and Zigbee, all the connectivity protocols, which even will be installed in any of the smart devices in the world. So that's what we say Silicon Labs is the leader of IoT wireless. So this is what I've been working into. So let's quickly start with the basic agenda. What we are talking to is an IoT. So let me make you a very interesting understanding. Where do we stand and where actually we use IoT devices in nowadays world in a very regular basis in our lives. So I think we'll talk in a perspective of students little. So hopefully you guys are nowadays in the pandemic situations working in online systems, working in Zoom calls, working in GoToMeetings, working in Skypes, having a call connected over and getting your tuitions done, getting your classes done, getting your even exams done in online. So that's where we see an IoT is. So on a regular basis, so IoT is interlinked to each and every one of us, where we actually comments up and say, yes, there's where I'm actually seeing the IoT. So even a homemaker or even a person who is actually working outside the world is all in any of the way is interlinked to the IoT. So let's quickly understand few of the day-to-day IoT examples which I actually have listed down. So I'm not saying that the list eventually consists of all the narrations here, but a very few things which we regularly see in our day-to-day happening lives. The connected appliances, if I talk about the connected appliances, so I can smartly tell you your smartphones, right? So you daily use your smartphones and day-to-day activity. When you just get up from your bed, you have a habit of peeping into your smartphones. The smartphone itself is an IoT device where you have an interlinked IoT has been connected. And the smart home security systems, so nowadays if I see the smart home security, even then you're not there in your home, but your actual home is under your control. You can have your surveillance of your home, you can monitor your home, you can control your home automations, you can control your lighting system, you can control your speakers, you can see someone has arrived your home or not. So that's where we are. Even I think even if you're not in India also, even outside India too, you have an option to sit back and see what's happening and peeping into your home. So that is where the smartness has been involved. That's where an IoT is. Coming to the farmer equipment systems also, we have an automated systems working in the farmers. See, example, I have an agricultural domain where the automation systems are working. So to the farming of an equipment, I can say that I have an automated farming equipment. Example, I just have to pour water to a plant without a human intervention. So I can say that the farming equipment is where we are actually using. And coming to the wearable health monitors, I think the best example nowadays, people are purchasing an online wearable equipments for health monitors. How much cholesterol actually I'm consistent, how much I'm draining my cholesterol in my day-to-day walk, how much I'm losing my cholesterol in day-to-day activity, what is my blood pressure nowadays, and what is my BP content, how. So these, what is your health monitoring system? So day-to-day you are being aligned to. That's where is called. So fitness freaks, this is what you're seeing your IoT is. the smart factory activities. So maybe the persons who are actually working in industrial sectors would definitely know what exactly the smart factory equipment is. The automatic door openers or automatic sensors, automatic triggers. And I think I'll go for a very basic example nowadays in the pandemic situation. One is the smart, what I should say, the soap dispenser and the smart hand sanitizer dispenser. That's a very very tiny an IoT device. That's where we see it's also an example of an IoT device. So the wireless trackers. So nowadays I think the trackers are being attached to kids or any of the older persons whom you actually want to track them. If you're even not sitting at home where they have went and you have to keep an eye on them. So that's where your wireless trackers comes. That is an IoT device. And coming to even wireless inventory, I can even say that you will have a smart cars. See, when you're actually walking onto your toll gate, there's the tags which detect you. The detection happens on online. So that is what an automation where you see an IoT is. And the internet and biometric, I even can't say a cyber security scanners, but biometric scanners are always we are doing. So nowadays people go to office or school or colleges, so I have a tag or I have a biometric system connected to the entrance of the reception. So unless you are scanned, unless you are monitored, unless they don't filter up and say that you are a part of that company or you are a part of that organization, you are not supposed to enter even the gate. They'll actually throw you out of the gate, right? So that's where an IoT is. So shipping containers in the logistics you have seen. So that way the tracking of the ships happen. So when you actually see in an overall way, this considers showing you, say that you are nowhere a human interaction. Without the human interaction, these are the automated systems talking to each other via internet. That is what we call it as Internet of Things over everything. So internet is everywhere where we are connected to each other. Virtually you say, because physically we are nowhere connected, it's nowhere even connected at the human intervention. So depending on these all the words I have shared, let's talk about the agenda, which I'll try to cover to make you more clear what exactly I'm talking about in today's complete session. So I'll be firstly focusing on what exactly IoT is. Okay. So because you people definitely would have heard about many definitions and abbreviations of what is an IoT is and how an IoT architecture is and what is and in that IoT people will be saying big data, cloud computing and cloud computing. What is cloud computing and what is data analysis? So these all the words you would have actually heard across, or when you are searching about the cloud computing in Google or any of your browser, you would have come across these words saying big data, data analysis, and some of the user interfaces and all. So I'll just make you a very simpler understanding where we are in IoT and what is the basic architecture of IoT and what is the significance of cloud computing in the IoT. Okay, let's quickly start with our discussion. As a very first part, what is an IoT? So IoT, I can abbreviate you and say it's Internet of Things, but all the examples which I have narrated before in the general day-to-day activities, I can't come up and say the definition as an example. So we should definitely have a single-phased example for what an IoT is. So that's where the definition of IoT is. The IoT or the Internet of Things is a system of interrelated computing devices, mechanical or digital machines or objects or animals or people or anything is provided with the UIDs, that we call it as unique identifiers, and ability to transfer the data over a network without requiring a human intervention. So I'm just talking about human intervention is negligible in the part. That is where things are connected over internet. I can even talk to mechanical data, a machine can talk while digital data or an objects or a data of an animal with sensors. So the sensor will be collecting the data. I think if you can see the very vast picturization of this, I have narrated in this way. See, we have an IoT enabled factories here and we have IoT shops here and some mobile devices. So we basically more people sit at this place. And some edge devices. I have written edge devices because most of the IoT devices are connected on a single edge piece. and certain chipsets, which I was just mentioning before, as per Silicon Labs, and certain data sensors and some home automation buildings and IoT enabled cities and trains. So all the things are actually connected to one of the cloud, that is what we are calling it as Internet of Things. So each and everything has a passable data, send it over to a single cloud. The connectivity can be different in any of the way. So I'm not saying connectivity can be same all the way, differs with the connectivity, and we viably have different appliances to talk to the cloud with different connectivity modes. So this was a very simple abbreviation of what exactly an IoT is. So coming back to the next point, now people are saying this is IoT, and okay, people have given me certain definitions for IoT, I have collected the data. Now how does actually an IoT look like as part of an architecture? So what do you actually mean by an architecture? I can abbreviate you saying IoT architecture is certain layers where IoT is physically sitting to. So IoT has basically 3 building blocks. Maybe if you can search it in Google, you will find more and more blocks, but let me make you more simpler. Whatever the blocks you take will sit into these 3 certain blocks itself. Okay. So the 3 major blocks which I am just trying to address you, one is things, the other one is a gateway, the other one is a network and cloud. So whatever equipment, whatever device, whatever technology you talk about in an IoT do come and fit into these 3 building blocks. So we actually call it as functional cum building blocks. Okay. So let's talk about what are things are here. So when you just see about presentation I made it here, see I can call the devices are sitting into the perception layer. We address this as a perception layer because it do consist of sensors and actuators. Okay. Let me make you more simpler. See, if you are sensing something, there is an obstacle sensor or there is a motion sensor, or there is some physical sensing has happened. That is where the sensors comes in your market, saying sensors. And actuators are something where we see the output. Can be either your bulb or either your bell or your calling bell or your output devices. Sensors are something which we call it as saying are being sensed. Example, for the soap dispenser or something, you keep your hand. That's where it's sensing is an obstacle, right? It's an obstacle sensing. Okay. So whenever entering the door for home, for automatic door opening, so that is where your sensing is sensor is being activated. Okay. And even a hazardous gas sensor, some of the gas has been triggered off and suddenly the sensor get activated. Some gas, so those are actually we call it as gas sensors, smoke sensors. So there is a pretty good number of sensors in the market rolling over. We have n number of sensors, that is something which are being sensed with some action. The action can be human made, the action can be things across you. That's where the complete things sit in the perception layer, which we physically see with our eyes too. So these are the things we actually see with our eyes. Next, coming to the network layer. Now a sense devices will have to sense its action to some of the extreme device with some connectivity zone, right? So then how do I actually send my data? Okay, now you are sitting, now I have sensed something, I have now it has to send again the data to someone else sitting at your home. So how does it actually send? So that is sending via Wi-Fi, or it can be via Bluetooth or Zigbee or any of the connectivity wireless mode what we are talking as a wireless protocols. Those come and sit into network layers, and we basically call it as routers or gateways. So we address it as a gateway because it's a gateway between the perception layer and your cloud. That is what is an application layer. Okay. So the routers and the gateways are where we are talking to each other via some connectivity. So these where the raw SOCs comes, like as I was talking about the Silicon Labs chipsets. So we address as a IoT devices. The wireless, the marketed IoT wireless devices come and fit into this zone. Next, coming to the application layer, the major important for our slides, the upcoming discussions for today, is what is an application layer. I'm just talking about the application layer. Application layer is something which we physically don't, it's not been visible to our eyes as of now. It's actually a cloud I can say it's a virtual cloud and it has been physically installed in some other system. And the cloud may not be with me as of now. It is somewhere, the hardware can be somewhere else sitting, but I can actually access that cloud as my database. That is where is a cloud. So the sensor data is sent back to network layer via some connectivity, and that particular SOC or something has sent the data to the cloud. Now what does cloud do? Now cloud has some action to do depending on the sensed action. Example, I am entering the door has to get open depending on your data. Example, I actually am an employee, example you or me or an employee of some company. Okay, I was just entering my biometric fingerprint. I was just entering my biometric, so it got sensed. Now the data that Asha Swarupa is trying to enter into the company, now my database, the data is actually sent to the cloud. Now what does the cloud do? Cloud try to match my biometric data with the database which is already saved inside the company org sheets. It will match and say, okay, now Asha is a employee of the company, let's open the door. So this is where your sensing action happen. So if I'm actually not the company girl or a guy, so obviously the door doesn't open for me, right? So this is where there is an action. So correlate everything which happens in your life with the IoT thing. So you will get pretty good number of examples in your life to analyze what exactly IoT is. So I think hopefully you'll get so many number of examples when you got up from the bed till you sleep. You'll come with so many biggest things happening in your life where without internet or without IoT, nothing would have been, nothing is actually possible in nowadays. Maybe I think when we consider the pandemic situations for past 2-3 years, right? Without internet or without IoT, nothing would have been actually so easy. So it's been so risky. But things are made pretty good number of easiness just because of happening of internet and IoT across all over the world. Okay. So this is what is an architecture is. So I can actually narrow down you showing a block level representation for IoT architecture, which I've already addressed you saying what is perception layer, network layer, application layer. This is what I already explained you before, responsible for distribution of content. So then the topmost layer which I was telling to you is called as a data management layer. So this is where I was just telling, collects the data from the learners and provide them to the learning data. Now it will fetch from data, it will modify, it will analyze the data and it will actually fetch back the output to the perception layer. So this is where the cycle where we are aligned to. Stepwise cycles to and fro actions do happen. So when you take up any of the IoT example, it will definitely come and fit into this architectural diagram. It's a simpler form. Maybe if you can search it in your any of the search engines or anything, you may see certain different diagrams or certain extra layers inside it, but definitely those also come and fit into these layers itself. Okay. So let's continue over the architecture. So I have figured out a few of the which I as per past discussions I was just telling you where we sit in and where the sensors comes, where the connectivity phases comes and all. So let's try and see these examples. Maybe it makes you more and more clear when I was just telling the pretty good number of examples in the past slides. Okay. So I think on the perception layer, if you can see, I've already mentioned there are n number of sensors in the world we have, and we have certain energy meters or some smart meters or anything, and the surveillance cameras. The biggest role which now market is actually playing with the surveillance camera. Okay. And the robotic arms, the kitchen robots, and the QR codes, and the barcode, panel PCs, portable PCs, card readers, RFID tags. So these are all the layers of, these are all the equipments inside the perception layer. So when I just talk about the surveillance cameras, right, nowadays it became a very crucial part of our life, the surveillance cameras. Okay, so we are being monitored everywhere. When you actually step out of your home, you're being under surveillance in any of the way. Are you driving? You are under surveillance. You are in a mall, you are under surveillance. Right. So the surveillance cameras are playing a major role in your life. As see, even then you are not at home, you have fitted your CCTV camera at your door or somewhere else you wanted to see and you can actually roll off your mobile and see what's happening in my home. Is what you are capable enough to actually monitor your home without your presence too. And nowadays robotic arms, I think a few of the robots came up for cleaning the floor, washing, whatnot has happened. Making a robot to cook, you would have seen pretty good number of ads coming up for the robots, right? And the QR codes, you would have actually seen these QR codes most of the time, right? You were scanning the QR codes wherever you actually wanted. Example, you were just entered the mall, you have purchased a shirt or something, you have been at the billing section, and you have given the cloth, and the QR code or the code has been scanned by the scanner. The barcode, the QR code. The QR code actually I resemble saying your phone pay scanners or any of the payable modes, right? And the panel PCs or the portable PCs and the readers. You would have seen about your card readers, your card detection readers, your ATM card readers or RFID tag readers, anything. So when you resembles, come back and analyze and see, oh, okay, my life is completely of all the n number of sensors I am accumulated across with. And when I was just talking about the communication layer, that which is what I addressed as a gateway and gateway part here, the connectivity part. I would say IoT as a gateway. So we have n number of protocols rolling up in the wireless communication. It can be a Wi-Fi, it can be Bluetooth, or it can be Zigbee, or it can be a small BS or Wi-Fi AP. So there are pretty good number of connectivity zones. That's where that's again a big chapter for your career understanding also. That is totally a big subject to roll with. And next, coming to the part of the industrial application. So now here where comes our outputs. Now these are being sensed, where are we actually using them on the day-to-day activities. That is what we call it as in some supply chain or food industry, smart grids or healthcare or internet or vehicles. So this is where we are actually using all our connectivity data inside these applications. So I think this is what is a very basic understanding where, what, how an IoT is and how the layers are being set it up, how each layer talk to each other, right? Right. So now coming to the very clarity picture of which layer is talking to what is where the protocol layer, which I was just telling you, we have n number of protocols where connectivities are connected via Wi-Fi or something. But I blindly come up and say Wi-Fi and Bluetooth are just a connectivity zoners, because in your phone you even have your Wi-Fi, even have your Bluetooth, but any connectivity do actually need some of the protocols. Those are examples. The samplation of examples are like this, but I can't say these are only the protocols which we actually use to talk to any of the cloud setting devices. It can be an MQTT, it can be a COAP or a custom or any of the protocols. So there should be some media of drivers, some media of layer which should talk from Wi-Fi hardware to your driver code to the storage device. That is where we call it as a protocol, Wi-Fi or wireless protocols. This is again a big subject when I was just telling. So people are actually to build up a career, people are even interested to build up their career at this part. This is where most of the, I think, EC graduates and embedded engineers who are actually interested into the core electronics and core communication control systems. So people are who are interested in that. I think engineers, I think you guys can connect yourself to the subjects which you are actually studying in your engineering graduations of BSc or anything which you are studying. You can correlate your subjects, right? So people who are actually interested in electronics and communications and embedded systems, or people who are interested in control systems can actually dig into these protocols and understand. And this is where is the section where you guys can fit in and analyze yourself and study what exactly these protocols and how actually I can send the data, how can I have a connectivity subject and all. That is where is a thing here. So now I'm just, okay, I have set it something, now my cloud is ready, it's stored somewhere, and the storage data is being pushed back with some contented data to the application. So that is where is your UI look like. I can talk about a UI, you can visualize your UI as your phone itself. See, when you just start navigating, browsing your phones somewhere, you will have a pretty good number of UIs coming up. Are you browsing your Amazon or browsing your Flipkart? When you're opening your WhatsApp, or you're opening your any of the chat boxes or anything. So when you the resemblance which is actually looking is called as a UI. The how pleasantly it looks to the audience, how pleasantly it looks to the user is what a user interface. So that's where is a big subject again, where people can sit in and do. Okay. So this is I think I will come back to this slide again when I'm just explaining you, well, I will be explaining you what exactly you guys can make up your career in your lifetimes. You can come back, see this all. I'll guide you to come back to the slide again and see where exactly you can fit into your careers in this particular perspective. Don't forget, I'll be back on this slide again to explain you more clearly. Now, when I was just talking about the connectivity, we as a Silicon branded Silicon IoT masters in wireless, so we have our own WSDK module. So this is what I think I can give you a very smart example of this thing. It inbuilt have a Wi-Fi, Bluetooth connectivity and certain sensors onto it. Okay, so this is the simplest SOC I could say, with certain radio board connectivities. There, the module itself is ready enough to send something and put the data onto the cloud via Wi-Fi or Bluetooth or Zigbee or any connectivity. So I think this is what is the smartest example. When you talk about a refrigerator, when you talk about your smart washing machine, when you talk about your smart TV, right? So there should be some sort of chipset should be there inside your TV, otherwise it won't run as smart as you can, right? And there should be something smart enough to make your washing machine smarter. In sense, your chip has, there should be some SOC inside it, right? So this is where is an example of SOC. There should be some SOC sitting at your, on the core of your washing machine or your TV or any of the AC or anything to get automated. That is what is the chipsets we call it as. So accumulately it depends on what hardware it is, but I'm just liably giving you a very simpler example from the Silicon Labs perspective product point of view. Okay. And coming to the biggest topic which I have to focus for today's discussion is what is a cloud computing. So now let's leave about the protocols, the wireless stuff. We'll come completely to the cloud computing. Now what is cloud computing is? So cloud computing is a dynamic provision of providing a hardware and a software services from a third party over a network. Okay. So cloud computing is an internet-based computing where shared resources and where all the shared softwares are provided to each other on demand. So cloud computing is a platform for next generation internet. I'll explain you if you can see the figure here. So there are pretty good number of laptops, servers, desktop, your tablet, your smartphones are sitting at, you people are actually sitting at, I mean you and me people are sitting at the sides of this cloud, right? So what exactly happens inside the cloud? So why we are actually calling it as a cloud and all, right? So the applications, so we basically inside the cloud we have a monitoring systems, a content analysis and a collaboration, communication, database, storages, block storages, platform. So these are all accumulatedly we call it as an application. This is what is called as a third party cloud. We call it as a third party cloud because I'll tell you, example, I am working on a project, okay? But I am actually having a lack of memory at me. I don't have certain big number of memory storages or hard disks at my place to store certain data, okay? Or if you are a new game developer, right? So you really have to have a big number of size of hard disks because I actually don't have certain sort of hardware and I don't have actually certain money to purchase that much of bigger amount of devices. So what do you do? That's where your cloud computing comes and helps you to purchase a space inside a physical machine. The machine can be sitting somewhere in the world, but you are trying to access the memory from that device virtually, you owning your space and you will pay for it. So you will pay as you use, that is what we call it as cloud computing. So this is where the word came up saying dynamic provisioning. So dynamic provisioning software, hardware, it can be viable. I'll tell you, we can even own up a hardware, we can own up software also. But for now, time being, let's make it more simpler. I can, example, if I own a complete software and hardware and I don't have any headache, I'll just come and sit, see the UI, I'll do everything, and I have data at my virtual cloud sitting. Now I have data ready with me. So someone comes and asks me to show the data, I'll just open the cloud of my instance and I'll show him, right? So that is where is the cloud computing. That much smart the cloud platform in the next generation is gonna be the biggest deal for the cloud computing environment. Okay. So in a very figurative representation, I think we can go with the next slide. Is a broad concept of Internet of Things to allow people to access technology enabled and the services. So something computer talking to cloud, cloud talking to computer, that is where is a simple way. And basically the name, this is actually named after the cloud representation on the network diagram, call it as cloud computing. So the network resemblance, we basically address it saying like this, this is what is our internet network diagram. We basically demonstrate in that way. Okay. Okay. So now we have told about so many stuff, what is cloud computing and how do we characterize it. Okay, so what is the characteristics of a cloud computing? So cloud computing basically works with the principle pay as you use. Now you have used more, pay for it more. If I've used less, pay less for you have used. Okay, okay. So that's where the word has actually been phrased of pay as you use it. So depending on the application, you may have a feasibility to use your space more and more. Please pay for it more. And if you're using very less amount, you are viably enough to pay less for it. So cloud computing customers do not own a physical infrastructure. What does mean by physical infrastructure? That is what I was telling you before. I don't have to maintain or keep a headache of maintaining a computer, analyzing it, computer, setting the hardware. If hardware is not working, I need not to come back and check my hardware or hard disk or any of the motherboard and check back and what's happening inside it. These blah blah things can't be. No, I am actually not bothered about the hardware. So that's where these cloud computing people have come up and given an environment. So we need not to have a headache of physical infrastructure. Okay. So instead of instead you can avoid a capital expenditure by renting your usage. So somewhere I think this would be a best example if I say you've been a tenant in your house. So that is what is actually happening in the cloud computing, right? So you don't have your own house, but you still pay for where you're staying. That is what we have, a tenant. So you being a tenant in your virtual machine, but the physical machine will be sitting somewhere else, but you being a tenant for certain days or certain time being, certain duration, you'll pay for that completely. That is where is called it as expenditure of third party provider. Okay. Now the consume resources as you serve and pay only for the resource you use. And I can list it down and say that there are few resources which you are liable to use. We will be only using few resources in the market, in the cloud. I am not capable, I mean for the project I may not be needed to use all the resources inside the cloud. I will be only limited to use few resources and I will pay for the only resources which I am using. So you have a feasibility to do that also. So you can't come back and say that no, I'm costed more for it. No, you're costed only to that extent you're actually using the resources or instances in that particular virtual machine. Maybe if we can, next coming slides will explain you what is an instance is, what is a resource is. Okay, we'll come back to that particular point too. Next coming to, there are basically broadly 3 levels of cloud computing, as you can see the figure. One is infrastructure as a service, that is IaaS, platform as a service, PaaS, software as a service, SaaS. Okay. These are the 3 broadly cloud computing levels which we talk about in the next coming discussions. The major IoT cloud computing is divided into these 3 divisions. The industrial people, the MNCs which are talking, the companies which are being tied up with cloud computing do come and fit into these 3 zones itself. Okay. Now firstly let's start with what is exactly infrastructure as a service. Okay. When I talk about infrastructure as a service, I actually even call it as I have written, I even call it as a hardware as a service. It is one of the layer of the cloud computing platform. So it allows customers to outsource their IT infrastructure such as servers, networking, processing, storage, virtual machine and other resources. Okay. So I'll tell you what exactly they meant is. As I told you before itself, I am not capable to own my own infrastructure. I am not capable to own up my own infrastructure, and I am ready to use others' infrastructure, right? If an X person is not ready to maintain the infrastructure, but the person B is ready to maintain the infrastructure, that is where I can say, okay, I'll own your infrastructure. Because I am not in a position to handle the storage and do the networking processing and all, right? So that's where the point has come up, saying customers to outsource their IT infrastructure such as servers, networking, processing, storage, everything will be the headache of the maintainers. So you will only take that particular support and you will implement your own traditional applications. Okay. In tradition hosting services, IT infrastructure was rented out of a specific period of time with some predetermined hardware configuration. So the client paid for the configuration and time regardless of actual use. Okay. So the client paid for the, so we actually pay for the configuration time which we are using regardless the actual usage. Okay. So how much you own, how much you use it. So this is where some of the companies come and say that, okay, we are the IaaS people. So we have everything, infrastructure is ready. You as a user come back to us, talk to us via your applications, via your third party host and talk to us so that we'll definitely ready to give you an IT infrastructure. So IaaS cloud computing layers eliminate the need of every organization to maintain the infrastructure. So there are small scale companies or some big scale companies, they don't want to maintain this certain headache. So they are eliminating that effort of maintaining an infrastructure. Okay. So even IaaS also provides you 3 layers of clouds, 3 types of cloud modelings. I can tell you a public, private and hybrid clouds. Okay. So the infrastructure where customer is trying to keep his own interest there. I'll come back to that private, public and hybrid clouds in the later of my slides. Let's stick to the infrastructures here itself. Let's stick to the services only here to limit up to this slide. Okay. So now in case in public cloud, it is located at a cloud and computing vendors in the data center and hybrid as a combination. So best both in public, private cloud can definitely be happened in even IaaS. So IaaS is something which even maintain a public, a private and a hybrid sort of clouds also depending on their viability, what actually they maintain. Okay. Then coming to the basic data centers, what exactly infrastructure do maintain. So IaaS lets you have a bypass, it's a and I'll just talk about the cost and complexities of buying and managing a physical service, right. So cost effectively, if you think that you have to purchase this much of hardware, you are actually supposed to purchase this much of hardware which have storage capability, we should have this much of processing speed, this much of RAM, this much of thing, and you will search back notify, you will all list it down and you will go to the market, you will search for it, you will buy it. So how much of headache it is, how much of time consuming it is, how much of cost consuming it is, right. So the companies which are actually branding and saying we support IaaS are making your life so simpler. Go back to any of the site and search it across it. No, they are ready to maintain the infrastructure. The only headache is you have to develop your application and talk to them. That's it. How the world has actually been so simpler and making it so easy, right? But even then, I don't say human is nowhere involved here. Human mind itself is something train them to do so, right? So we people, so that's where we start and dig our careers, what we actually have to do there. So that's where we come. Of course, definitely, I'll say that human intervention is nowhere. So to make, without human intervention also, human is needed to automate them. That's where our human brains sit in and do, that's where we build our careers also. Okay. So including, I just missed your point saying including a middleware, including the operating systems. Now, example, you purchased a Windows machine, you have put it your OS or a Linux machine, you install your OS and all the drivers, installing all the drivers, installing all the UIs, installing all the licenses. How much cost it actually vulnerably takes for you to do that complete setup, right? So sit and imagine. So this complete headache is actually gone. So installation, configuration, setting it and everything in middleware application of everything is set up and ready. I'm actually only supposed to use what I'm actually using to. That's it. So that is where an IoT with IaaS, that is called infrastructure as a service do mean. Okay. So I'll tell you few of the companies which are actually we are talking about providing an IaaS. That is IaaS, that is we call it as Amazon Web Services and Microsoft Azure or Google or IBM. I think you have heard, a pretty good number of people have heard about these all the branded companies which do provide this cloud services. Okay, so maybe Amazon Web Services or Google or Cloud or Azure or anything. These all the, I am not saying these are only the limited companies, we have pretty good number of companies even listed out, but I have just listed out for sample example which few people have already listened before. So, so these are all the clouds which sit back and say our infrastructure is ready, our storage is ready, our component is ready, our space is ready, our network is ready, everything is ready. Just come back, create an instance in our clouds, talk to us, pay for what you're using. That's it. So how simple is it? So customer need not to have a bothered about specifying what kind of hardware you want to use it. So that is what I have actually mentioned here. So customer need not to be bothered about specifying what kind of hardware you actually need it. Okay, so hardware perception filtering we need not to bother be about. The real meaning is to rent someone else's hardware for a minute or hour monthly basis, right? This is actually, when I was just reading this statement, right, I felt pretty good. That is what we are actually doing this in the real-time marketing. You are renting someone's hardware for a minute or for an hour, for a half an hour, and I am saying that okay, my work is done, I paid for you. But if you are using to use your project for longer duration, you can own it for a certain extent too. So I'll tell you what exactly the biggest highlights of IaaS are. On-demand computing resources eliminate the need of a head planning. Far head planning is actually being eliminated. This is on-demanded computing resources we have, and no upfront commitment. Start small and grow as you require. So if you are a learner or a student, you don't know what exactly to, how exactly to. So you are just go with a small amount of investment on top of your cloud. So start with a small investment, and later on as you keep growing up or working up in your cloud related stuff, you pay for it. So grow as you require, right? So no contract, no credit card, nothing doing. Okay. So I have been on contracted for certain time, you will pay for certain duration only when you are willing to do. So pay for what you are using, that's it. Okay. So no maintenance is required from your end, no measured services are required, and it is so scalable and it is so reliable, so secure too. This is a very basic highlights of an IaaS devices, and we'll come about platform services also. I have already mentioned you in this way. So platform services is a cloud computing. So this is one of the other service, when I was just talking to the infrastructure as a service, this is the second service where I am talking to is a platform as a service. So platform as a service is also one of the service where a third party provider delivers the hardware and tools to users over the internet. Okay. So, so PS providers host the hardware and software on its own infrastructure. As a result, frees the developers from having an installation in in-house hardware and software to develop a new application. So I'll tell you now, you will come back and say me infrastructure and PS also looks like the same to me. It's also providing hardware, it's also providing software, and what way these are actually being used up, right? So I'll explain you very clearly in what exactly PS is. So these are actually the few of the companies which we talk about PS services, that is AWS Lambda, you can call it as a Salesforce, you can call it as a Morpheus or something. So these are internet infrastructures. I think more of the people would have heard about Salesforce.com, right? I was seeing plenty good number of ads on Salesforce.com, which comes up with not only infrastructure but also a programming language platform. So this is where is the biggest difference from IaaS and PaaS is your programming language infrastructure is also available for you to develop your own applications there. So as IaaS maintain its own application, its own UI, its own connectivity, everything, while coming to the platform as a service, the platform is provided as a service to you, and it's given a UI application or a programming language support where you can write your application and customizedly talk to the hardware. So the thing is, they are renting a platform to you, you are actually been rented for that platform. So you can your feasible application. So they'll create a platform for your programming languages to sit in and talk to the cloud. That's where I think as a software developers who was actually working in Node.js or anything, you can keep talking to them via some of the examples also, right? So that is where, so I can actually explain you with this slide also how actually the PES works. So as I mentioned in the previous slides also, PES does not replace complete entire IoT infrastructure, for software development. So it provides a cloud provider hosted infrastructure. Okay. So even PES do have hybrid public and private clouds also, but the thing is it has an infrastructure to talk to the cloud with your own application domain, so where you can build your application. So if you guys are so serious about your software programming, you are capable enough to write your complete coding part and you are ready to talk to your cloud and make your data ready, that's where you fit in. You come back and write your applications, make your device talk to cloud with your some of the programming languages. So it do provide certain wrappers to you where you have to sit back and narrate your own wrappers, APIs, and you have to write accordingly. Okay. So I think I have actually mentioned here in the slides certain Java development or any application hostings or Node.js or .NET or whatnot softwares. Bear me because I'm not so good at that software verbality also. So the software people will coming back and talking to the PSs. Okay. So there's again a part of version saying, so the web services integration. So PS comes as development team, application design, application testing, web design, web services, information security, database integration. So these all basically comes into the PES works. Okay. So I think the most of the CSC, IT people or any of the software guys who are actually capable or interested to do the coding part and build their own application and development and services. So that security integration or database management, you people are more and more welcome to sit into these work, these companies and put your own interest to dig into the and understand what exactly these services are and where I actually can fit my career. So next coming part to the software as a service, as we are discussing infrastructure platform. So software as a service allow the users to connect and use cloud based apps over the internet. So the basic common example I can narrate you and say your emails or your Outlooks or your Office tools and your Microsoft Office, right? So that is something which is giving you utility to talk to the cloud via your web or user interfaces, right? So that's where I can call it as software as a service. So these all the outlooks which you are talking, so even then this also, even I think I'll give you a best example for the Gmail also. When your drive is actually being overflowed, you have to purchase something to purchase the memory for that. So nowadays the Gmail is actually getting overwhelmed, I am not sufficient Gmail drive for me, right? So you will go back, purchase certain memory and you will again keep using it. So depending on your usage you will purchase certain. So that is what I am saying, pay as you go. That is what is software as a service. So intent for these all the things we are maintained, the others are maintaining the infrastructure, but in the very first case I am only using complete infrastructure with complete software and everything, that I am only purchasing certain instances, I am creating my own instance and creating my data there, that's it. While coming to the second one, infrastructure, I can develop my applications and I can talk to cloud via this. Now software as a service is something where the software outlines are being analyzed and it allows you to connect to the cloud via certain connectivity. So I can give you the best examples, I have already told you before, certain Google apps like Gmails or Office 365 or Salesforce or Box or your Dropbox or whatnot. So these all have a UI based services. It provides software applications through the cloud and you have a and this SaaS has actually been over past more years. So these SaaS, I think the older one, because the free email services have been more classical for pretty good number of past days across, right? So this is the design that someone can offer the hosted set of software running on a platform. So the best examples are the older one, I can say Yahoo. Nowadays people are not talking about Yahoo, but Yahoo and Gmail or Google and whatnot you have been. So the email services offered are something like a SaaS one. Okay. So these are what actually the infrastructures. In upcoming slides we will be seeing what exactly different sort of clouds we do have. Before we start with the next upcoming sessions on private and public and hybrid clouds, let's take a very quick break. I'll be back with all the external details what we are actually talking about in the agenda. So we'll be back soon.